Hello and welcome to lecture number 4 of the LQAS online series. As we addressed the tabulation process in the previous lecture, in this lecture we will use tabulated data and make further calculations in preparation for analysis of data resulting from using LQAS. We will take a closer look at how indicators are obtained for the entire program area, as well as confidence intervals. But more importantly, how to start the analysis of these results in order to make management decisions at the local and program levels. Specific objectives for this particular lecture include how to calculate indicators for the entire program area. We will also be able to understand how to calculate weighted coverage rates for the entire program area based on population size of supervision areas, as well as 95% confidence intervals for population-adjusted coverage rates. We will also start looking at how to classify supervision areas and to determine whether a supervision area is at high risk or at low risk based on data collected through LQAS. Let's get started by taking a closer look to indicators for the entire program area. As you may recall from our first lecture, this is a table that summarizes one indicator being analyzed: the percentage of deliveries attended by clinically trained providers in our program area. To calculate this coverage estimate, we identify all the correct responses in each of the supervision areas, and based on the total sample size, we come up with an average coverage, which is an estimate for the entire program area, as we aggregate data from each of the supervision areas where we collected this information. For our particular example, that average coverage estimate is calculated by dividing the total number of correct responses, which for this particular case is 42, over the total sample size, which gives us an average coverage of 44.2% as indicated in the slide. Now, based on the estimated average coverage and the sample size, we make use of the LQAS table for decision rules in order to identify a decision rule per supervision area. You may recall that we use this particular LQAS table for decision rules, and we made use of a couple of parameters, that is the sample size shown in this column on the left side of the table, and also the coverage benchmarks or average coverage represented in the columns in this particular table. You may also recall that in real-life projects, though, we will not always be able to have a sample size of 19 in each supervision area. As you see in this table, supervision areas B, D, and E have sample sizes less than 19, which will translate not only into the total sample size being different, which is now 91, but also into different decision rules per supervision area. Let's take a look at another couple of examples. Here's a summary tabulation table with 6 supervision areas and 3 indicators being assessed. As you can see, we have indicator number 1, assessing the percentage of children 0 to 5 months of age who are exclusively breastfeeding. Indicator number 2, assessing the percentage of mothers of children aged 0 to 5 months who know at least 2 signs of childhood illness that indicate the need for treatment. And indicator number 3, assessing the percentage of sick children aged 0 to 5 months who received increased fluids during an illness in the past 2 weeks. Let's take a look at how we calculate the value of indicator number 1. We add the number of correct responses in each supervision area, and those are 10, 15, 10, 7, 9, and 10. And we also add the total sample size from all 6 supervision areas, which for this particular example, it has been 16 as the sample size for all the supervision areas. So by aggregating the total number of correct responses, which is 61 for this particular indicator, and aggregating the sample sizes for each supervision area, that will give us a total sample size of 96, we will be able to calculate the average coverage for this particular indicator, which for this case would be 63.5%. So the value of 63.5% represents the average coverage for indicator number 1. And again, this is the result of dividing the aggregated number of correct responses, 61, over the total sample size, 96. Likewise, we do the same for indicator number 2, adding the number of correct responses from each of the supervision areas as indicated here. That will give us a total number of correct responses of 48. And then we divide these by the total sample size, which for this case it has been 13 in each of the supervision areas, and gives us a total sample size of 78. So in other words, the average coverage for this particular indicator number 2 is 61.5%. The same thing we could do for indicator number 3, aggregating all the number of correct responses from each of the supervision areas. That will give us a total number of correct responses of 54. And we divide this number over the total sample size used in this particular indicator, which for this case, it's 97. So the average coverage for this particular indicator number 3 would be 55.7%, which is the result by dividing 54 over 97. Let's take a look at another example with more indicators being assessed. In this summary table, we can see not only how different sample sizes relate to different decision rules, but also analyzing larger sample sizes as we aggregate data from 2 questionnaires administered to mothers of children 0 to 11 and mothers of children 12 to 23. As you can see in the title of this summary table, we are assessing 5 indicators for children aged 0 to 23 months of age. Like the previous summary table, we calculate average coverage rates for these 5 indicators by aggregating the number of correct responses and dividing the total number of correct responses over the total sample size. You can see that due to different sample sizes in each supervision area, we have different decision rules per supervision area. Having this structure in the summary tabulation table will allow us to quickly identify which supervision areas need more attention by indicator. For instance, indicator number 2 that assesses the percentage of children aged 0 to 23 months with diarrhea in the past 2 weeks who have received oral rehydration therapy. We can immediately tell that supervision areas 2 and 3 fall below the decision rule. Through these summary tables, we can flag which supervision areas require more attention than others. In addition, you can see that for indicators 1, 4, and 5, we have sample sizes larger than 30. And for this reason, we want to present an additional LQAS table for decision rules that will let us identify decision rules for those cases where we have more than 30 as a sample size per supervision area. Here is the LQAS table for decision rules with sample sizes larger than 30. This table will allow us to identify decision rules for larger sample sizes when we aggregate data from 2 questionnaires or maybe 3 used in parallel sampling framework. For instance, from the previous summary table, we had an indicator that had an average coverage of 75% and a supervision area with a sample size of 43. Therefore, the decision rule is 27 as indicated from this table.